Hi children, good morning. How are you? How is COVID-19? I think you are safe at homes. How you are enjoying your holidays, children? By using television and by using the mobiles, I think so. Yes, for your sake only, we are going to start our online classes. Have you remembered me? This is your Jyoti ma'am. I am going to handle the science subject. Let me see the branches in the science. In the science, we are having three branches: physics, chemistry, biology. My part is physics and as well as chemistry. Biology part will be started by the biology teacher. Now, let me go for the contents what are present in the physics. In the physics, let me see the contents, children. The first chapter is motion. Next, force and laws of motion, gravitation, work and energy, sound. So totally we are having 5 chapters in physics. Next, let me go for the chemistry. In the chemistry, the first chapter is matter in our surroundings. Is matter around us pure? Atoms and molecules. Structure of the atom. So totally we are having the 4 chapters in the chemistry. Now let me start the physics. Okay children? Yes. What can we observe on the roads, children? Vehicles. Moving of the vehicles. Few persons will be walking from that side to this side. The birds will be flying. We are having the seasons also, children. How it will be possible? Yeah. Rotation of our earth. Rotation and as well as revolution. This one all comes under, yes, that is our topic. That is the motion. Today, let me discuss about the motion chapter. Yes, let me go for the definition of motion. Let me discuss about what and all we are going to learn in this motion chapter, children. Motion at rest, distance and displacement and its SI units, uniform motion, non-uniform motion, differences between distance and displacement, speed, velocity, differences between speed and velocity, acceleration and its SI unit, equations of uniformly accelerated motion, graphical representation of motion, distance time graph, speed time graph, derivation of equation of motion by graphical method, uniform circular motion, calculation of speed of a body in uniform circular motion. Now, let me discuss about describing the motion. What do you mean by motion? Motion is a change of position. What do you mean by motion? Motion is a change of position. How it is going on? For example, you are sitting in the class. Just ma'am called you. So, sitting in the class is nothing but a rest position. From your position, you are moving towards your madam. So, then what has happened here? Change of your position is nothing but the motion. Motion is a change of position. Let me consider one example. A school in a village is 2 kilometers north of the railway station. So what here we are going to tell? Where is the school? In a village. So in which direction is 2 kilometers Railway station is the reference point. And to describe the position of an object, we need some reference point. That point itself we call it as the origin. If you think in a school in a village, the school is 2 kilometers north. 2 kilometers it is towards the north. So, north of the railway station. So, the point we call it as the reference point we call it as the origin. The reference point we call it as the origin. Let me see the definition for the motion, children. An object is said to be in motion if it changes its position with respect to its surroundings and with time. Let me see the examples. Moving cars, buses, train, cricket ball, etc. All the planets revolving around the sun. Molecules of gas in motion above 0 kelvins. Rest. An object is said to be at rest if it does not change its position with respect to its surroundings and with time. That means, for the example, mountains, buildings, these and all will be in the rest position. It won't move from one place to another place. So while sitting in the classroom, you will be in the rest position. While you are moving, that means from bench to bench or from your place to your blackboard. If you are coming means, once again you will be in the motion position. That means from rest to the motion position. Rest and motion are relative terms. An object which is at rest can also be in the motion simultaneously. For example, the passengers sitting in the moving train are at the rest each other, but they are also in motion at the same time. The object, for example, the objects like trees, buildings, etc. So, this is the relation between the rest and motion or relative terms. So, you are going to get a doubt about this. How the motion and rest or the relative terms. Here we can see the figure that the earth is rotating and also revolution is taking place around the sun. In the examples of motion of a ball and a car, man is considered to be at rest. But the man is standing on the earth and the earth itself moves around the sun as well as rotates about its own axis. Therefore, man is at rest, the earth but is rotating and revolving around the sun. Already I have discussed starting as an example for the motion. That's why motion and rest are relative terms. Next, let me go for our topic, motion along a straight line. Here, let me see one example. From the origin, that is the starting point, that is origin point O. An object is moving towards. So, how many kilometers here I have denoted with the letter A? It has more 50 kilometers now. So, what is the distance it has moved? That is OA is equals to 50 kilometers. A person is moving along this, and once again he has come back and he had met the B. Now what will happen here? What is the distance he has traveled? Totally OA plus AB. How much the distance is OA? Is nothing but 50 kilometers. And how much once again when he came back? What is the distance he has traveled? 15. So come back. Here the difference between these two is 5 kilometers. So 5, 10, 50. 50 kilometers. So totally he has traveled 50 plus 65 kilometers. So how much distance he has traveled here? 65 kilometers. Once again he has came back from B position to C position. Then how much distance he has traveled? Totally we are having the 50 kilometers. he came and met the B. So that is a 65 kilometers. For that, we have to add 10 kilometers. So totally 75 kilometers he has traveled. So like this, we can calculate the motion in a straight line. So the total distance covered by OA, A to B is like C. Now let me go for magnitude. What do you mean by magnitude? The numerical value. Numerical value means these are 20, 25, 30, 35. This one called as the numerical value. The numerical value of a physical quantity is its magnitude. So, maybe it is a 20 or 25, 30. One numerical value it should be. So, that numerical value we call it as the magnitude. So, if we see OA and the person who is traveling from O to A, and once again he came back to B. That means from A to B. The distance covered. What is the distance covered? From O to A, we are having the 50 kilometers, and back to A to B, here we are having the 50 kilometers. Totally, he has traveled as 65 kilometers. This is the distance traveled, not the magnitude. This distance covered by O to A and A to B. This is the distance covered, distance traveled. It doesn't come under the magnitude. Next, let me go for distance. The total path length covered by the object is nothing but the distance. Distance means what we are going to travel from where to where. It describes about the distance. So, the total path length, how much it is covered by an object is nothing but the distance. To describe this distance, we need to specify only the numerical value. Only we need a particular value. That means how many kilometers from here to there, or from a school to railway station, or from one place to another place. We are going to tell only particular numerical value. And not the direction of motion. From here to, if you want to go to your village, which direction, how, from the north side or the southern side, no need to specify that. How many kilometers we are going to travel, it is okay. So, to describe the distance, we need to specify only the numerical value and not the direction of motion. Now, let me see what is displacement. The shortest distance measured from the initial to the final position of an object is known as the displacement. It means starting point to the ending point. So, what we know? Initial point. Initial point as I have assumed as A, and the final position of an object B. So, here we are denoting with the 2 points. The shortest distance measured here, the shortest distance we are going to measure from where we are going to measure? From the initial to the final position of an object. So, from initial position to the final position of an object which we are going to measure is known as the displacement. The shortest distance measured from the initial to the final position of an object is known as displacement. Let me see the SI unit. SI unit of the displacement is meter. Let me see the distance. Distance traveled by a body is the actual length of the path covered by it, irrespective of the direction in which the body travels. Here you can see in this figure, a person is moving towards to the north, and in a straight line he is moving. How many kilometers? 5 kilometers. After that he has changed its direction. So he is moving towards to the north 2 kilometers. So total the distance travelled is 5 plus 2. 5 kilometers plus 2 kilometers is nothing but 7 kilometers. So here once again he is coming back from the straight line. He has moved 5 kilometers. Once again he is coming back to the 5 kilometers. So totally 5 plus 5 is 10 kilometers. So what is the distance traveled by a person here? Is 10 kilometers. Let me see for displacement. Displacement of a body is the shortest distance between its initial position and final position along with direction. Here, the direction is important, children. So in this figure, what it is happening, see, a person is moving towards to the 5 kilometers, and once again he is moving to the north. But where is the starting position? Starting position and final position. Here one arrow mark, it shows the final position for us. So here the displacement is 6.57 kilometers in the direction shown above the arrow mark. So totally he has traveled 6.57 kilometers. Once again you can see in the second figure he is moving towards straight. Once again he is coming back. So where is the starting point? Where he has started itself, it's the starting point. Where is the ending point? Once again he had came back to the same position. So the distance traveled here is 10 kilometers, but the displacement will be the 0 because it is showing only the initial point. Where is the final point? So both the initial and the final point is the same. That's why the displacement is 0 kilometers. So let me see the conclusions about the displacement. The displacement is a vector quantity. Here we have to learn about the two types of quantities. One is the scalar quantity and one is the vector quantity. A scalar quantity, it doesn't mention the magnitude, but for the displacement, magnitude is must. So the displacement is the vector quantity. The displacement has its units of length. The displacement of an object in a given time interval can be positive, 0 or negative. The actual distance traveled by the object in the given time interval can be equal or greater than the magnitude of the displacement. The displacement of an object between 2 points does not tell exactly how the object actually moved between those 2 points. So there the example problem we have seen that a person is moving, total displacement is 6.57 kilometers. So here that point will be explained for us. The displacement, actual distance traveled of an object in a given time interval can be equal or greater than the magnitude of the displacement. Then let me move for the point 5. The displacement of an object between 2 points does not tell exactly how the object actually moved between those points. The displacement of the particle between 2 points is unique path, which can take the particle from its initial to the final position. The displacement of an object is not affected due to the shift in the origin of the point position axis. Now let me see the differences between distance and displacement. Distance is a scalar quantity. Displacement is the vector quantity. Distance traveled by a moving body cannot be 0. Final displacement of a moving body can be 0. Now let me see what is the scalar quantity and what is the vector quantity. So displacement, we told that it is the scalar quantity. Let me see what is the scalar quantity. Scalar quantity is the physical quantity which has only magnitude. This is important. So scalar quantity is the physical quantity which has only the magnitude. That means, let me see few examples. Length. How much length? So here we are going to measure mass, time, speed, energy, etc. So these are the examples for the scalar quantity. Next, another quantity also we are having, that is nothing but the vector quantity. The vector quantity is a physical quantity which has both magnitude and as well as direction. telling about the magnitude. Only magnitude is present. But in the vector quantity, we are having the both, that is magnitude and as well as the direction. Both the magnitude and as well as direction is nothing but the vector quantity. Vector quantity is the physical quantity which has both magnitude and as well as direction. Example, displacement, velocity, acceleration, force and etc. So let me back about the scalar quantity. Here you can observe the scalar quantity is the physical quantity which has magnitude only. Example, length, mass, time, speed, energy, etc. Vector quantity. Vector quantity is the physical quantity which has both magnitude and as well as direction. Example, displacement, velocity, acceleration, momentum, force, etc. Next, let me see about uniform motion and non-uniform motion. Uniform motion. When an object travels equal distance. What is that, children? When an object travels equal distance in equal interval of time. When an object travels equal distance in equal intervals of time. Let me go for one example. A car is traveling for 1 second 1 meter. Next, another second, it is traveling the same distance as 1 meter. Next, another second, it is traveling the same distance as 1 meter. So, totally, for the 3 seconds, it has traveled the 3 meters distance. So, what we can observe here, the time is, we are having the equal intervals of the time and the distance traveled also will be the equal. So, this motion we can say it as the uniform motion. When an object travels equal distance in equal intervals of time, we can call it as the uniform motion. And next let me go for non-uniform motion. Here, when an object travels unequal distance, this should be the equal. When an object travels unequal distance in equal intervals of time. For example, the same example we can take here. For the first second, a car has traveled 1 meter distance. For the second, it has traveled 2 meters. And for the last second, that is the third second, it has gone for only half meter distance. So what here we can see the variation. For the first second, it has traveled 1 meter distance. And for the next second, it has gone for 2 meters. That means the distance, we can see the difference here. And for the third second, it has gone for only half meter. That means for the 3 seconds, it has traveled the 3.5 meter. That means it has taken the unequal distance in the equal intervals of the time. This one you can tell it as non-uniform motion. When an object travels unequal distance in equal intervals of time is known as non-uniform motion. Let me see here, children. Uniform motion. A body has a uniform motion if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. So, we can call it as the uniform motion. Now, we can see the non-uniform motion. A body has a non-uniform motion if it travels unequal distances in equal intervals of time. So, what is non-uniform motion? A body has a non-uniform motion if it travels unequal distances in equal intervals of time. Is known as non-uniform motion. In this class, we have learned about what is motion, what is distance, displacement, magnitude, and uniform motion and non-uniform motion. So, tomorrow class, still let me learn about the few concepts.